Hi, my name is Farah McDonald, and I will be giving a presentation on the complicated risks associated with the adoption of autonomous vehicles in urban areas. As a litigation attorney, I previously worked for a law firm that represented a major supplier of autonomous vehicles in litigation regarding the safety of their vehicles. Autonomous vehicles, often referred to as self driving or driverless cars, are equipped with sophisticated technologies like sensors and cameras and advanced computing systems. They are guided by AI, and these vehicles possess the ability to navigate and make decisions independently. They mimic the decision making of a human driver. And although there are some benefits to the adoption of autonomous vehicles in urban areas, such as enhanced road safety, increased mobility for the elderly and disabled, and improved traffic flow, fuel efficiency, and alternative fuels, there are also some complicated risks associated that need to be addressed as well. This project examines the complicated risk associated with the widespread adoption of autonomous vehicles in urban environments. Specifically, it focuses on the risks to public safety, regulatory compliance, and urban infrastructure. And it addresses how unpredictable factors such as software malfunctions, cybersecurity threats, and pedestrian interactions impact the reliability and safety of autonomous vehicles. Now, I have identified 5 risk categories that have the highest potential likelihood and impact of risk on the adoption of autonomous vehicles in urban areas. The first is software reliability. The second is cybersecurity threats. The third is infrastructure readiness. The fourth is public interaction and behavior. And the fifth is environmental factors. Looking at the first risk category, software reliability. Autonomous vehicles operating in urban areas face several software reliability risks due to the complex and dynamic nature of these environments. Urban areas present a challenging environment due to the multitude of pedestrians and traffic and irregular road layouts. Errors in processing sensor data can lead to misinterpretations of the surroundings, and that can result in incorrect decisions. Additionally, in urban areas, GPS signals may be obstructed by tall buildings or underground infrastructure, and this could lead to a compromise in positioning accuracy. Additionally, autonomous vehicles rely on seamless integration of multiple software systems, including navigation, object recognition, and decision-making algorithms. And failures or conflicts between these systems can hinder reliability. Urban environments require rapid and complex decision-making due to sudden changes in traffic conditions. Delays or inaccuracy in real-time processing can lead to unsafe actions or failure to react properly. This factor contributes to the overarching enterprise risk because it increases the likelihood of accidents and reduces public confidence in autonomous vehicles. Now, looking at the second risk category, cybersecurity threats. Autonomous vehicles face growing vulnerability to cybersecurity threats due to their reliance on advanced connectivity and communication technologies. The most critical risks stem from their integration with the internet, onboarding Wi-Fi services, vehicle to vehicle, and vehicle to infrastructure communication. And this features, and it also has features such as over-the-air firmware updates. So attackers can exploit the advanced driver assistance system, the sensors of the autonomous vehicles to create deceptive scenarios. An example of this is a hacker projecting false obstacles that could trigger unwarranted braking, while concealing real hazards that could lead to collisions. And this could pose as a significant safety concern. Additionally, autonomous vehicles collect and process vast amounts of data, creating potential security threats to user privacy and data security. So, autonomous vehicles gather sensitive personal data such as location history and biometric identifiers, driving behavior, and even user preferences. A data breach could expose this information to unauthorized parties, leading to identity theft or misuse. This factor contributes to the overarching enterprise risk because it could lead to major safety incidents and security concerns. It could also erode trust in autonomous vehicle systems. Now, looking at the third risk category, the infrastructure readiness. This, brings out the need for robust infrastructure. Um, the successful use of autonomous vehicles in urban areas depends on infrastructure readiness. Urban areas often have worn or inconsistent road signs and lane markings, making it difficult for autonomous vehicles to interpret their environment accurately. This can lead to navigation errors or unsafe driving behavior. Additionally, potholes and uneven surfaces and other road maintenance issues can confuse autonomous vehicle sensors and lead to vehicle damage or incorrect decision making. And again, this factor contributes to the overarching enterprise risk because poor infrastructure reduces autonomous vehicle performance and increases risk. Now moving on to the fourth risk category, public interaction and behavior. And we're going to be looking at, navigating human dynamics. Okay? Autonomous vehicles in urban areas must navigate complex interactions with pedestrians, cyclists, and other road users. Urban environments are filled with a lot of pedestrian activity, including jaywalking, sudden movements, or pedestrians ignoring traffic laws. Autonomous vehicles may struggle to predict and react appropriately to this behavior, increasing the risk of accidents. Additionally, cyclists often share the road with vehicles in urban areas, but their movements can be unpredictable, such as weaving through traffic or ignoring dedicated lanes. This can confuse autonomous vehicle systems. And then finally, human drivers in urban areas are known to exhibit aggressive and erratic behaviors at times, such as cutting off other vehicles and rapid lane changes or ignoring traffic laws. These actions can inhibit the autonomous vehicle's ability to respond safely. This factor contributes to the overarching enterprise risk because it directly increases safety risk in urban areas. And now for the final risk category, environmental factors. And this is talking about adverse weather conditions. Autonomous vehicles face significant challenges when operating in adverse weather conditions, which can impair their sensors, decision-making algorithms, and overall performance. Precipitation and low visibility can obscure cameras. Ice or dirt accumulation on sensors can cause them to malfunction. Slippery roads from rain or snow or ice can cause roads to become slippery and increase the risk of vehicle losing control. So heavy rain can cause hydroplaning, which makes it difficult for autonomous vehicles to maintain control. So this factor contributes to the overarching enterprise risk because it reduces the reliability and safety of the autonomous vehicle when dealing with those adverse weather conditions. My sources of existing data to evaluate the risk of autonomous vehicles in urban environments are the traffic incident data from the Department of Transportation databases, publicly available autonomous vehicle testing data from companies like Tesla or other companies that manufacture autonomous vehicles. Research studies on pedestrian and driver behaviors, cybersecurity reports on vulnerabilities in autonomous systems, and city infrastructure data like road quality, smart system adoptions, and things like that. Now, the data that is needed but lacking is real-time accident data specific to autonomous vehicles. And then also comprehensive cybersecurity breach data specific to autonomous vehicles as well. So now that we've located our data sources, we can test their validity by cross referencing data from manufacturers, such as crash rates, with independent test organizations or insurance databases. We can also identify outliers, such as unusually low accident rates that might indicate underreporting. After verifying the validity of my data, I'd use the data to analyze with other sources, such as doing predictive modeling to assess how infrastructure and software reliability impact accident probabilities. Modeling is a quantitative analysis, and it refers to the use of statistical techniques and machine learning algorithms to analyze historical data and make predictions about future outcomes. The goal of it is to identify patterns and relationships with the data that can help predict future events, behaviors, or trends. Another thing I could do is use disparate data integration. Um, and I could use that to overlay environmental condition data like weather patterns with autonomous vehicle performance metrics to identify high risk zones. And the disparate data integration is the process of combining and unifying data from different sources or systems. The goal of it is to create a cohesive data set that allows for meaningful analysis, reporting, and decision making, despite the differences between the two data sources. In conclusion, the adoption of autonomous vehicles in urban areas presents both significant opportunities and complex risks. While the vehicles promise benefits such as enhanced safety, increased mobility, and reduced environmental impact, their integration into existing urban environments has its challenges. The risk identifies like software reliability, cybersecurity threats, infrastructure readiness, and public interaction highlight the need for careful consideration and proactive measures to ensure that safe and effective operation of autonomous vehicles in urban areas, that it is done, that it we have that safe and effective operation of those vehicles. The model built that I discussed earlier during my presentation, as well as the predictive modeling and the disparate data integration, it serves as a valuable tool in understanding the risk associated with autonomous vehicle adoption. By combining data from diverse sources, these approaches can help identify high risk areas and inform decision making processes, ultimately guiding to the development of regulations and technologies that enhance the safety and efficiency of autonomous vehicles.